Hi everyone, this is Thiagarajan, retired Deputy Chief Engineer from Indian Railways. So in this video, I'm going to discuss about the extra clearance on curves and track and curved track and Indian Railways. We need some clearance for any moving dimensions. We need some clearance on both sides of the vehicle in view of the safety of the passengers who are traveling the train, or any unforeseen situations, like goods train, the door will be in open condition during running, and sometime, even we used to carry, some over dimensioned consignment in the goods train. So considering all those things, the how much clearance you are supposed to provide. So that has been calculated, that has been prescribed in the Indian Railway schedule dimensions for broad gauge. That we are supposed to follow whenever we are laying the track and whenever we are constructing any structure by side of the track. For example, the platform, at what distance should be there, considering the gap between the footboard of the train and the platform, so that the passenger should not by mistake step into the gap. At the same time, the footboard should not hit the platform. So considering those things, that has been derived and it has been prescribed in the schedule dimensions. At the same time, whatever structure, for example, any post, at what distance should be there from the center of track, and any building, any structures on the platform, or any foot or bridge landing, or for platform shelter, the projections. So everything, at what distance it should be there from the center of track, everything had been stipulated. We are supposed to follow that. But whatever it is given, it is only for the straight track. The alignment is straight. The track alignment is straight. That we can follow that. But in the case of curved alignment, it is not so. We need some extra clearance. That is because of the curvature of heads, and because of the super elevation provided in the track, because the vehicle will be leaning towards inside. So considering those situations, so we are supposed to provide some extra clearance, and they are to be calculated. That we are going to see how they are to be calculated, and how much we are supposed to provide, how much should be inside of the car, how much should be the outside of the car. So all those things we are going to discuss in this video. So when the train is negotiating in a curve, we need some extra clearance. That is because of curvature effects. For example, in case of inside of the car, we need to provide the extra clearance because of the curvature effects, and because of the lean due to superelevation, and sometime because of the vehicle sway also. There will be some oscillations. As far as outside of the car is concerned, and we are supposed to provide the extra clearance due to curvature effects only. So, and what is a curvature effect? So, normally curvature effect means we used to say it is overthrown and through. That means whenever the vehicle, train is negotiating the curve, the wheels will be following the curved path, but the coach will be straight because it is a rigid body. It is not bending, it is not flexible. No, it is not bent for the alignment of the curvature. It will be straight only. So since it maintains straightness, there will be some projection, and inside and outside, that we used to say it is throw. So normally because of that, there will be projection inwards at center. That we used to say it is overthrow. And some extra projection will be there outside at the ends. That we used to say it is a end throw. So we have the overthrow, end throw. So how it comes into play, and how they are to be calculated, that we are going to discuss in the coming slides. This is your straight track. This will be your coach position when the trains are running in a straight track. So while the train is running in a straight track, and both the wheels and the coach position will be following the straight alignment. To follow the straight path. And another thing you should look into here, this is your bogie arrangement, that is set of wheels. The entire assembly used to say it is a bogie. Like that we used to have the two bogies, and there is a pivot arrangement, and in the entire body of the coach is seated on these pivots. So this will be independent. So when there is a movement in the curved path or whatever maybe this will independently, it will travel, it will follow the curved path, though it maintains straightness. This will follow the curved alignment. Okay. So this is in the case of straight track. This is the position. But when the train is running, negotiating on a curved alignment, so you can just look at here. Okay, the bogies, the wheels will be following the curved path, whereas the coach, being a rigid body, okay, it maintains straightness, and it will not bend. Okay, it is not flexible. No. So that is why, because of that, there will be some throw. The projection will be there. If you say here you can see it's called overthrow. So whatever projection, it just shifted from this is your center of the track, this center of the body, but it is just not following the alignment of the track. It just shifted. This amount of shift we used to say it is called overthrow. Amount of throw is called to overthrow. Whatever throw it takes place inside of the curve, it's called to overthrow. So ultimately there will be some extra projection here. And look at here the ends of the coach in the outside. So there will be projection. This is called end throw. Okay, this is called end throw. So this end throw and overthrow, okay, is coming into play in the case of because of the curvature effects. So how they are to be calculated? We'll see here. So using the Versine formula, you know pretty well the Versine formula. The Versine formula is, what is the Versine formula? V equal to c squared by 8r. So V is equal to the Versine, okay, the mid-ordinate. Okay, when you are when you take this is arc, the mid-ordinate you used to say it is a Versine. If you want to find out this throw, this Versine, okay, the c squared by 8r. C means, let us take this is our chord length, and r means that is a radius of the curvature. Okay, so using the relation we will be able to get the V. Okay, so in case of overthrow, it is coming to 14.785 squared divided by 8r, because 14.75 what is normally we have taken a standard coach maximum. This is your 14.75 will be the distance between the two pivots. Okay, so substituting here, so we are getting the overthrow will be equal to 27,330 divided by r. Okay. Similarly, we can find out the end throw also. So end throw how much? Here this is your end throw. That means let us take here. This is your end throw. Let us take this is total chord length, total Versine minus this Versine will be your net. Okay, throw. So we have to calculate total length of the vehicle we have to take. What is the length of the vehicle? This is 21.340 meter. Okay, so substitute in place of C, we are substituting 21.34 squared divided by 8r. That will be the total Versine. That means from edge to edge, let us take this is your chord length. So Versine will be here. That will be 21.34 squared divided by 8r minus this amount, this overthrow, minus this amount will be your end throw. Minus means what? This is overthrow, as already discussed, 14.75 meters square divided by 8r. So combining this one, we are getting this equation. So end throw equal to 21.34 squared minus 14.785 squared divided by 8r. So ultimately V equal to 29,600 divided by r. Here equal to is missing. Kindly put up. Okay, this will be your equation for end throw. So using these two relations, we are able to get the overthrow and the end throw. More the radius, okay, lesser. It is inversely proportional. Okay, it is inversely proportional. Since r in denominator, sharper curve will be having the more throw, flatter curve will be having the lesser throw. Okay, like that. Okay. This is about the curvature effects. This is about the overthrow, end throw. Okay, the end throw, it is coming in the outwards, outside of the curve. Overthrow playing inside of the curvature. Okay. Okay, now we will see about the effect of superlevations. Okay, normally we are providing superlevation on curved track. So when the trains are negotiating a curve, vehicle will be leaning towards inside. The amount of lean is calculated using the relation L equal to h into Ca divided by G, where h equal to height above the rail level, and Ca is equal to cant actual, that is actual superlevation, and G is equal to dynamic age of the track. So as far as BG is concerned, we take 1750 mm. Okay, and also the additions we are considering. That means always there will be some lurch, some oscillation will be there. So because of some minor irregularity in the track. So that actually we are considering 1/4 of the lean what we are calculating using the relation. Okay. So this is something about it, and we will see in detail how the lean is being calculated here. So this is the vehicle position when the vehicle is on a straight track. When it is in a canted track, this will be the position. So whatever amount of superlevation we are given, inclination, same inclination the vehicle will have. Okay. So this theta equal to this theta. Okay, angular inclination equal to here, because of the track, will be equal to angle of inclination. Okay, of the tilted vehicle. Okay, so now we will see. We will take this triangle here. We can apply sine rule because relating your hypotenuse on the opposite side. Because sine theta equal to opposite side divided by hypotenuse. Here is opposite is Ca, cant actual superlevation, divided by gauge will be your sine theta. So sine theta equal to Ca by G. Similarly, since both angles are same, it is similar triangle. So we can take this triangle here. We want to know the L. So L equal to how much you have to calculate. So here also we can apply the sine rule. So sine theta equal to, so opposite side by hypotenuse. So opposite side how much? L divided by hypotenuse is height of the vehicle above the rail level. So sin theta is equal to L by H. So equating both. So L by H equal to Ca by G. So L equal to H into Ca divided by G. So lean equal to height of the vehicle above rail level into Ca, that is actual cant, superlevation provided on the track curve, and divided by the dynamic gauge. So this is the relation for finding out your lean. Okay, this is actually directly proportional to your cant actual. So more the cant, more will be the lean. Okay, this is. And similarly, as already discussed, sway also you have to consider. Sway, how much you are considering? That sway equal to 1/4 of the lean, that is LV4. Okay, this is about the lean and the sway. And in general, to summarize, normally extra clearance, inside of the curve, what we are getting. Inside of the curve, we have overthrow because of the curvature effect, and lean due to superlevation because vehicle is leaning towards inside due to provision of superlevation. This is an equation. And vehicle sway also we are calculating, considering, that is 1/4 of the lean what we are calculating out of the second equation. So this everything, all three will come into play in case of inside of the curve. Okay. So whenever we are having any structure or in this thing, when we are having some clearances provided the head dimension, apart from that, the extra clearance we have to add as far as inside of the curve is concerned. Similarly, for the outside, we have to consider only end throw. That is the equation. VE equal to 28,600 divided by R. So this is an equation. This is the value of end throw. Okay. This is something about the extra clearance. And coming to the platform clearance. So whatever we discussed here, same rule you have to apply here. But here, what we do some relaxation we are giving it, because this is our platform. We have the tracks, and sometime the vehicle will be received on one line. Platform will be the outside of the curve, and sometime the platform will be inside of the curve. So in this case, how much extra clearance we are supposed to provide. So as already discussed, inside of the curve, what we are doing inside of the curve, all will come into play. That is overthrow, lean and sway L/4. So this will come into play. It will correct. But we are deducting some 51 mm as far as inside of the curve is concerned. Suppose we are here actually. So how much extra clearance we have to provide? We have to provide extra clearance because of our overthrow and because of the lean effect and because of sway, 1/4 of the L. All these things come into play. This will be your total extra clearance. But minus 15 mm we are giving as per raw dimensions, because when we are giving more clearance here, what will happen? There will be some extra gap will be there between the footboard and the platform. So because of the excessive gap, by mistake, passenger may step into the gap, okay, result some accident. That is why, to avoid that, already the whatever clearance is given, it's sufficiently available. That is why they are given some relaxation. That means instead of full clearance, extra clearance. So we are supposed to provide some reduced clearance. That means total clearance required out of these three equations, and minus 52 inches we are reducing it. This will be your inside curve clearance as per the platform when it is existing in the inside of the curve. So in case of outside of the curve, when the platform comes, normally outside, only the nth throw will come into play. That is V. So, but here, instead of full clearance, instead of providing full clearance, we are deducting 1 inch. That is V minus 25 mm we are putting. This same way to reduce the gap between the footboard and the platform edge. Okay, this is all safety consideration. This excessive clearances may cause passengers to fall between the track and the vehicle. Okay, this is as far as platform clearance is concerned. Okay. Okay, now we will see about the adjacent track clearances. Suppose there are two parallel tracks. Okay, in this case, how the extra clearance has to be calculated. Suppose if you take an inner track, train is coming in the line. The end throw, the vehicle end throw, that will project towards the outer track. Okay, like if you take the outer track here, the overthrow that will project towards inner track. So these things to be accounted, and of course sway we have to consider. But as far as lean is concerned, we are not considering here, because trains are coming in both lines now. Okay. Assuming that the both tracks having the super elevation equally are provided. Okay, same super elevation are provided. So lean also will be same. So this train will be leaning towards inside this way, and this train leaning towards this way inside. It will be parallel. So the lean effect will not be there. They will not consider that one. But we have to consider the sway. Sway here we are considering the double the sway effect we are considering, because suppose the both trains are coming, the oscillation will be in opposite way. So this inner track train oscillation will be inside, and outer track oscillation will be inside. So there are chances, it may happen. That is why, for safer side, and we are supposed to consider double the sway as far as this extra clearance as far as curved parallel tracks are concerned. Okay, is something about it. How, suppose calculate the combined throw. So we have to add end throw VE and overthrow also. So both throw we have to consider, and sway we have to consider double the sway we are considering here. So total the extra clearance, how much is that VE, the end throw effect and overthrow effect, plus double the sway. But we don't consider the lean here. Okay, so this is something about the adjacent track clearance. Okay, how it is to be calculated. And in case of mast between tracks, suppose there are two parallel tracks, but in between mast is there. But in this case, we have to independently consider with respect to mast, whatever clearance required, we must ensure. Okay, with respect to mast is concerned for the inner track, and as far as outer track is concerned, the clearance we have to calculate independently to the mast. That is, if you take an inner track, so what will happen? There will be, for the mast, extra clearance will be enthrow only. As far as outer track is concerned, so all three will come into play. That means the overthrow and lean effect and sway. All those things we have to consider here. But outer track, why we are not considering the sway in this case? Already, this will be leaning towards inside. Okay, because superelevation, even though there is oscillation, this will be within the lean only. That is why normally we don't consider, sway for the outside of the track. Okay, that thing you have to understand. Okay. Then another thing I want to say, whatever thing we have calculated, worked out, it is for a vehicle having 21 340 mm long with bogie centers 14 70 mm apart. Okay. Suppose when you have different dimensions of the vehicle, suppose running in the particular section, and the maximum dimensions we have to consider, and further you have to calculate and the extra clearance and see that it is properly ensured at site. Okay. Then special consideration for group A routes. So normally, we have to have the forethought, and always, so in case of particularly in the group A routes, there are potential for higher speeds in future. So that is why normally maximum superelevation, we can go up to 180 pm, and for that, you have to calculate and see that the clearance is calculated and provided, and the length of transition also accordingly we have to consider. Okay, for the maximum CAT assumption. Okay, so this is about the special consideration for group A routes. Okay, for future consideration. Okay, and also I have just displaying the pages of Indian Railways schedule of dimensions for BG. Okay, IRSOD. It is something about extra clearance. Okay, it's detailed instructions available that also you can go through. That is 46, page number 46 and 47, and whatever discussed, the same way they have given some explanation calculations, and you can also follow this one. Okay, and 46, 47, 48, 3 pages, the entire thing had been mentioned. Okay, so that also you can go through. Okay, so thank you, we'll see you in the next video.